guys, welcome to another interesting topic. Today on Sweet Science, we'll be looking at plotting of graph plotting. Let's start. We first of all put up our coordinates. We have our vertical line drawn. The line running down is our vertical line, and the line that will cut across here, this is horizontal, our horizontal line. So we now name our lines. Our center zero is the origin of the graph, is the center zero. AOB, and we have COD. AOB is the vertical line. Know it now. Line AOB is the vertical line. Line COD is the horizontal line. Now, line AOB is our y-axis. Is our y-axis. And COD is our x-axis. X-axis. We now have AO, line AO is our positive y-axis, and OB is our negative y-axis. Let's do it this way. If we have the lines this way, we have 1, 2, 3, 4, 5 from O to A going up. O to A going up is 1, 2, 3, 4, 5. Now O to B, we have -1, -2, -3, -4, can have up to -5, and so on. As you are going down, it goes down, and here you put the arrow, goes up, can take up any value. Now we have again OD. OD is our positive x-axis. OD is our positive x-axis, and OC is our negative x-axis. Our negative x-axis is OC. So we can name them this way: 1, 2, 3, 4, 5. Can continue with the arrow. Then we can also -1, -2, -3, -4. So this is negative x-axis. Negative y-axis goes down, and then here is the vertical, here is our horizontal. Many students, they always make that mistake. They keep asking which one is vertical, which one is horizontal. The line AOB is your vertical line, while COD is the horizontal line. The next thing we need to do is to get the equation of a straight line graph. Equation of a straight line graph. For us to do that, to get the equation of a straight line graph, we have our axis drawn. Let's put up our axis. Now, if we now have our line, the line of best fit drawn, passing through the origin, we have the line of best fit drawn, passing through the origin. Here is y, here we have x. Then we have here angle theta. We can make a square here, and then here we have, this is our O, let's have A, let's have B, and then we can have C here. If we can use trig ratio. When we use trig ratio to find tan theta, it is what? Opposite. Tan theta is opposite all over adjacent. Opposite over adjacent. And from this graph, our slope, the slope of this graph is equal to AB all over OB. And here is Y, here is also Y, and here is X. And AB, we can say is Y all over X. Now, this is our slope, and then we can give our slope a name. It's a constant. We can use M to represent our slope. M is equal to our slope, and our slope also is equal to tan theta, which is equal to Y all over X. If we represent our slope with M, we now have that M is equal to Y all over X. Making Y the subject of the formula, we now have that Y is equal to mx. This is the equation of a straight line graph passing through the origin. Y is your dependent variable, X is independent variable, and then M is the slope of the graph. So we have that Y is equal to mx. And then our Y, remember, is dependent variable, M is the slope, X is independent variable. And this is representing equation of a straight line graph passing through the origin. Now we want to now put up another equation that will include the one that will not pass through the origin, but we cut this y-axis at a point. So let's put it up. We have this line, our vertical line drawn. Then we now put up our x axis, this is y axis, this is x axis. And remember, we said the line of best fit now is not passing through the origin. See our origin here, see our origin. Then we have to draw our, want to draw and cut up our triangle. We want to get our triangle, and then here is theta, here is our triangle we want to look at. Here is point D, here is A, O, let's have here point B, and we now have that. Remember, this line that we join here is also our y-axis. This is our y-axis. This is our y-axis. This is our y-axis. This is our y-axis. Then between here, from here to this point is C. So this is C. You're getting it, pay attention. From this point to here is C. From here to here is C. We now also have that this line, from this line A to line B here, what will it be? It's now y minus C. It's y minus C. And then here is our x, and here is our small y. Here is our x, here is x, here is y. Already here is also y. This line is y, this line is our y-axis. Here is our x-axis. Remember, tan theta is equal to m and is equal to what? opposite all over adjacent. And our opposite is what? Y minus C. All over adjacent is what? X. Pay attention. Let me take it again. From this A to line B is Y minus C. And we are considering this triangle. Triangle. That's what we are looking at. Now, we said that tan theta is equal to M, which is equal to Y minus C all over X. Because tan theta, already we said, is opposite over adjacent. Opposite over adjacent is our tan theta. So from here, M is equal to Y minus C over X. And mx is equal to y minus c, making our y the subject of the formula. That is the dependent variable. If you make it, the subject of the formula is equal to mx plus c. mx plus c. So c is now what you call intercept. Intercept. C is your intercept, X is your independent variable, M is your slope, slope of the equation, slope of the graph, and then of the equation. Then Y is your dependent variable. Let me take it again. Y is your dependent variable, M is the slope, X is the independent variable, and then C is the intercept. This intercept can occur anywhere. Here is plus because it's on the positive side of the y-axis. It can also occur on the negative side of the y-axis. And when that happens, that's why we now have our equation of the straight line graph to always be in this form. Y equals mx plus or minus c, plus or minus c. So the intercept can be positive or it can be negative. Let's use this equation to drive home our point. If you have this equation, y is equal to, you have 2x plus 3. Y is equal to 2x plus 3. Let me write it well. We have y is equal to 2x plus 3. From this equation, if you have this equation before you, from here, you have that y is the dependent variable. 2 is the coefficient of x, and coefficient of x is the slope. That is m. Alright? Is the slope. So this 2 is this m, is equal to this m, which is the slope, and then x is independent variable. Then the intercept of this graph is plus 3. You can always make up your table of values by doing this. Let's quickly do this. You can assign values to x. You can select x, have the values from 1 to 6. So when you now have, you can have this way, you can do it this way. You can now have, this is our, we put our x here, then we put our y here. 1, 2, 3, 4, 5, 6. So when x is 1, what will your y be? If x is 1, so y is now equal to 2 times 1 plus 3. That is what we are doing. 2 times 1 plus 3. That is what we have. Then what will it give you? It will give you what? 2 times 1 plus 3, 5. So here y will be 5. The next one, y is equal to 2 times 2 plus 3. This will give you what? 4 plus 3, 7. Then y is 2 times 4. Sorry. Okay, 2 times 3 plus 3. That will give us what? Times 3, 6 plus 3, 9. You have 9 here. Then have y is equal to 2 times 4 plus 3. That will give you 2 times 4, 8, 9, 10, 11. Then y is equal to 2 times 5 plus 3. That will give us times 5, 10, 13. Then y is equal to 2 times 6 plus 3. That will give you times 6, 12 plus 3, 15. So now give us 15. That is our table of values. You can actually use this to plot your x-axis, plot your y-axis, and when you calculate the slope, you will now see that the slope of this, when you plot these values, the slope of it will give you 2, and then the intercept will give you 3. Thank you for watching. We will see you in the next video where we take up how to scale your graph, how to choose your scale. See you then. Thank you.